Good afternoon, viewers. Again, I'm Teacher Betty, continuing with the molar concept under the topic molarity. This time, 2013, paper 1, number 24. 25 cubic centimeters of 0.05 molar sodium hydroxide solution was neutralized by 20 cubic centimeters of 0.02 molar acid. Which one of the following is the molar ratio of the reaction of hydroxide to the acid? We are given A, 1:1, B, 1:2, C, 3:1, and D, 3:2. Such questions, where they need mole ratio, you have to observe that they give us the volume and the molarity of the reactant, and also the volume and the molarity of the second reactant. So for this case, we have to get the moles that are in 25 cubic centimeters of sodium hydroxide, and then the moles that are in 20 of the acid, after which we get the mole ratio. So moles of sodium hydroxide in 25 cubic centimeters. We say the capital M means the molarity, and the molarity is the number of moles contained in 1,000 cubic centimeters. Therefore, 1,000 cubic centimeters of sodium hydroxide solution contain 0.05 moles. What about 25 cubic centimeters of sodium hydroxide will contain, we cross multiply 0.05 times 25, then divide by 1,000, which is equal to 0.00125 moles. So these are the moles of sodium hydroxide in 25 cubic centimeters. Similarly, we go and obtain the moles of the acid that are contained in 20 cubic centimeters. So moles of the acid in 20 cubic centimeter. Capital M, to remind you, means molarity, which is 1,000 cubic centimeters containing those moles. So 1,000 cubic centimeters of the acid contain 0.02 moles. What about 20 cubic centimeters of the acid will contain, we cross multiply 0.02 times 20 over 1,000, which is equal to 0.0004 moles. So having obtained the moles that are in 20 of the acid, we can as well go and get the mole ratio. So mole ratio of the hydroxide to the acid. You put the moles that you obtained for sodium hydroxide under sodium hydroxide, which is 0.00125, to the moles of the acid, which is equal to 0.0004. Now, you look for the smallest and then divide it throughout. The smallest is for the acid, over 0.004 over 0.0004. This is 123.1. But moles are always whole numbers, so this is the same as 3 to 1. And our answer is C. Activity 3 is obtained from, again, 2013, paper 1, number 37. I told you there are many ways of using molarity to land on whatever you are requested to calculate. Now this time, we are required to calculate the molarity, but we are only given the volume and the mass dissolved. This question can be tempted in two ways. We can either first get the moles that are contained in 500 cubic centimeters, or get the concentration in grams per liter of the calcium hydrogen carbonate. Let us first use the first method. Moles of calcium hydrogen carbonate in 500 cubic centimeters. How do we get these moles? By getting the moles that are contained in 6.48 grams of calcium hydrogen carbonate. I told you the moment you are looking for moles and you are given mass, you have to go straight to the relative formula mass of a given compound. So RFM of calcium hydrogen carbonate. This is the same as calcium plus 2 hydrogen atoms plus 2 carbon atoms plus 6 oxygen atoms. So this is the same as 40 plus 2 times 1 plus 2 times 12 plus 6 times 16, which is equal to 162. We said a mole of any substance is numerically equal to the relative formula mass of that substance. Therefore, we can get the moles that are in 6.48 grams. 162 grams of calcium hydrogen carbonate contain 1 mole. What about 6.48 grams of calcium hydrogen carbonate? Will contain, we cross multiply, 1 times 6.48 over 162, which is equal to 0.04 moles. So since they dissolved 6.48 grams, and these are the moles that are in 6.48 grams, therefore the moles in 500 are equal to 0.45. We can as well get the molarity. We have seen that 500 cubic centimeters of calcium hydrogen carbonate contain 0.04 moles. What about 1,000? Remember I told you the moles in 1,000 is the molarity. Therefore 1,000 cubic centimeter of calcium hydrogen carbonate will contain, now we cross multiply, 0.04 times 1,000 divided by 500. This is the same as 0.08 moles. That is the molarity, and our answer is C. So that is the first method. The second method is to obtain the concentration in grams per liter, or the grams that we are dissolved in a liter. Then we can use those grams to calculate the molarity by finding the moles that are contained in that liter. To remind you, this was the relative formula mass of the calcium hydrogen carbonate. We can leave it here because it will be used later. So concentration in grams per liter of calcium hydrogen carbonate. How do we get that? We are told 500 cubic centimeters of calcium hydrogen carbonate contain 6.48 grams. What about 1,000 cubic centimeter of calcium hydrogen carbonate will contain, we always cross multiply, 48 times 1,000 and then divide by 500, and the answer is 12.96 grams in a liter. So having obtained the grams in a liter, we can as well go and get the moles that are contained in these liters. Remember, the moment you have grams, you go direct to the RFM. And we said a mole of any substance is numerically equal to the relative formula mass of that substance. Therefore, 162 grams of calcium hydrogen carbonate contain 1 mole. What about the grams in a liter? Will contain grams of calcium hydrogen carbonate will contain, then we cross multiply 1 times 12.96 over 162, which is equal to 0.08 m. So those are the moles that are in a liter, and the same answer as in the first method. I told you we can use molarity to obtain whatever is required by the examiner. This time we are requested to determine the basicity of the acid. What is basicity of an acid? These are the number of hydrogen ions that can be obtained from 1 molecule of an acid. So let us see how many hydrogen ions are in this reaction. The question is obtained from 2011, paper 1, number 26. 25 cubic centimeters of 0.25 molar acid required 25 cubic centimeters of 0.5 molar sodium hydroxide for neutralization. The basicity of the acid is, we are given objective A as 1, B as 2, C as 3 and 4, and D as 4. So for questions which have got molarity and volume, we have already seen them. So I told you, you always get the moles that are in 25 and then of the acid, and the moles in 25 of sodium hydroxide, after which you get the mole ratio. Let us see. Moles of the acid in 25 cubic centimeters. So to remind you again, capital M means molarity, and molarity are the number of moles in 1,000 cubic centimeters. So 1,000 cubic centimeters of the acid contain 0.25 moles. What about 25 cubic centimeter of the acid will contain, we cross multiply 25 times 0.25 over 1,000, and the answer is 0.00625 moles. So these are the moles of acid in 25 cubic centimeter. Let us also look for the moles in 25 of sodium hydroxide. So moles of sodium hydroxide in 25 cubic centimeters. Capital M means molarity, which is in 1,000. So 1,000 cubic centimeters of sodium hydroxide contain 0.5 moles. What about 25 cubic centimeter of sodium hydroxide will contain, we cross multiply 0.5 times 25 over 1,000, which is equal to 0.0125 moles. So having obtained the moles for both reactants, now we can go and get the mole ratio. Mole ratio of the acid to sodium hydroxide. The number of moles for the acid were 0.00625, then to those of the hydroxide 0.0125. We divide by the smallest, and the smallest is for the acid, which is 0.00625 and 0.00625, which is equal to 1 to 2. So always you have to get the value that is under the base, which is 2. So the basicity of the acid is 2, and our answer is B. Another activity is obtained from 2012, paper 1, number 24. Now this time they are not asking us molarity, though we are given the volume of the monobasic acid. We are told monobasic acid, so there are different acids. We have monobasic acid. Such acids are written like H, X. We don't know the radical, but we know the hydrogen ions. Mono stands for 1, so that is 1 hydrogen. There is diabasic acid. Di means 2. This means that it has 2 hydrogen ions. And then tribasic acid. Tri means 3, so it has 3 hydrogen ions. Don't mind about the radical, provided you know mono means 1, di means 2, and tri means 3. This X can change to A or can change to any letter. For this case, we are given a monobasic acid. How? 10 cubic centimeters of a monobasic acid reacted completely with the 20 cubic centimeters of 0.05 molar sodium carbonate solution. The number of moles of the acid that reacted are. So now, in the previous example, I told you must know the property of the acid, how they react with the carbonate. Always, they react with the carbonate to produce a solid, water, and carbon dioxide. The equation is the monobasic acid reacting with the sodium carbonate to give us a solid, which is sodium X, plus carbon dioxide plus water. So we have to balance the equation. We have 2 sodium atoms on this side, so we come and balance it. I told you whatever you are balancing, you bring it in front of the molecule. So this means 2 times sodium, 2 times X. So my X has also changed by 2, come in front of the monobasic acid and introduce a 2. This means 2 times hydrogen, 2 times X. So my hydrogen is also 2. The equation is balanced. Back to the question. 10 cubic centimeters of a monobasic acid. I put 10 cubic centimeters. React completely with the 20 cubic centimeters of 0.05 molar sodium carbonate. 20 cubic centimeters of 0.05 molar sodium carbonate. The number of moles of the acids that reacted are. So for this case, we are going to get the moles that are in 10, but not in 1,000. So moles of sodium carbonate in 20 cubic centimeters. As usual, capital M means molarity, and molarity is the number of moles contained in 1,000. So 1,000 cubic centimeters of sodium carbonate contain 0.05 moles. What about 20 cubic centimeters of sodium carbonate will contain, we cross multiply 0.05 times 20 and then divide by, and the answer is 0.001 moles. So these are the moles of sodium carbonate in 20 cubic centimeters. So let us go and get the moles of the monobasic acid in 10 cubic centimeters. I told you, having obtained the first moles, always you have to go to the mole ratio. Mole ratio of the monobasic acid to sodium carbonate, which is equal, the value in front, which is equal to 1. What does this mean? It means that 1 mole of sodium carbonate reacted with 2 moles of the acid. What about these moles I've obtained? 0.01 moles of sodium carbonate reacted with, we cross multiply 2 times 0.001 over 1, which is equal to 0.002 moles. So these are the moles of the monobasic acid that are contained in 10. Since only 10 cubic centimeters of the acid reacted with sodium carbonate, so the moles of the acid that reacted are equal to 0.002 moles. Now, since our answer, the objectives are not in this format, you go on calculating until you come to the answer. And our answer is A. So with that, you can find more examples on the website of dictoteachers.co.ug.
Muli kuki tuli mu basi mulagawa tawuni kyanaku kikabya ukabya kivo kya digito muze kwa nalogo. Eno basi tekyalina mataala, eno basi tekyalina mipiira, eno basi indiketa za ndali. Mugive mangu temufiiramu, neje mulaga teriyo mulamwa, kujjako okugwa mu binnya n'okufiira mu njaga. Mubeesige yasigaza bigambo, mayimayi azunga buzungu. Muli kuki tuli mu basi mulagawa tawuni kyanaku kikabya ukabya kivo kya digito muze kwa nalogo. Mwasomako twasoma luzungu, kati mukolawa tuli ku street. Mulya biki? Tulya mandazi. Musulirira ki? Tusulirira pani kyanaku. Muli kuki tuli mu basi mulagawa tawuni kyanaku kikabya ukabya kivo kya digito muze kwa nalogo. Kituuka katako tuteekwa buteekwa, kituuka katako tusaana kukyusa. Twenda pulezidenti mulala, twagala musomesa, twagala Dr. Bosa Science atuwe vaccine, atuwe treatment, atuwe solution. Akitegedde tegeeza omulala, atategedde tokoppa bukoppi. Kyannaku muli kuki? Tuli mu baasi mulagawa tawuni. Kyannaku kikaabya bukaabya kivo kya digito muze kwa nalogo.